Hey, we should be live. Okay.
Yay!
And we'll just I'll pop over
How's it
to
going?
VMware. I've
That
just
doesn't help
realized
if you
an
can't just go
interesting
to our channel and
I've just realized when you
see
hit
the video there.
just realized when you hit go live, like if you don't factor in for the 30 seconds of lag, YouTube will happily stream whatever 30 seconds you were talking about before you start the stream, which in our case was just like,
Just
you know,
garbage.
me
Yay!
last minute prepping stuff.
It's all good. It's the first stream of the year.
Yeah,
Going.
to anybody's wow, all 0 million viewers. I'm gonna put it
Zero
like that. Yeah,
million.
0 million. Wow. Although let's be honest, we've been on break for the last. Well, I mean, it was holiday time in Australia, which I don't know if anyone's watching this from overseas in the future. Well, it was an interesting holiday time. Um, so that was fun. And then last week, Jake had something on. So this is our first of the year.
Is
Um,
it?
we do have plans to be a bit more organized. We sorted out a bit of a schedule. We thought through some future stuff. So we'll at some point. Oh gosh, it sounds like I'm making a promise that we're not going to follow through on, but at some point publish our kind of schedule. So when we're streaming, roughly what we'll be streaming, with a level of uncertainty because sometimes things change,
Mm.
and when we might not be. So if uh,
There is also a backlog of
yeah,
um, videos from Twitch that we haven't done anything with that we might think about.
I've got them somewhere, but
Yeah.
otherwise, yeah, it's just kind of that sort of getting organized, and then yeah, we've kind of landed on we'll stream on Tuesdays at well 8 p.m. AEST or Australian Eastern Standard Time. Jake lives in Queensland, so they don't do daylight savings. So
Nope.
um, that'll just be when we. So if you're up there, it'll be different. But if you're around the world, it's 8 p.m. AEST, plus 11 GMT at the moment. But that's all good. So that's when we do our thing, and then when we're busy. So sometimes things come up on a Tuesday. We used to try and move to a Thursday, but we sometimes weren't really good with that, and we often found that it didn't really work anyway. So we figure if we can't stream that week, we won't stream, but we maybe have some other stuff we're gonna do as well that it was a bit more kind of like planned stuff rather than stream. Well,
Yeah.
not that the streams aren't planned, but
New Year's
let's
resolution: be organized.
yeah. But looking, we playing around with the idea of maybe doing like a monthly something similar to a podcast or something. So something that's done in advance that we polish up, rather than a stream which can sometimes be pretty cash.
Yeah.
So let me just, uh, for my own paranoia, check that this is working in YouTube.
Okay, I already checked it and it's fine.
Sweet. The streams aren't planned, but yeah, there we go. Oh, we've picked up a few more subscribers though. Apparently, we have 22 now. So,
Nice.
whoa. Uh, also, for full disclosure, our goal is to get. Man, this is a lofty goal to get to like 200. Full transparency, at 100, you get your own URL in YouTube, and figured, well, why not double that? So, tell all your friends. If that's well, gosh, man, I'm so out of practice.
Yeah, me too.
Just tell all your friends.
Come watch us fail at doing security stuff
Or
and laugh at us and
communicating.
then subscribe.
Well, like especially today's one. So, if you remember back a while, Jake, do you remember that we were working on a little script to like find secrets that may be in files? Um, and I think we got it to the point where we could look for variables called password and check for like RSA keys in files as well. Uh, fun note: I had to do a bunch of this somewhere recently, and it's a really common problem to find config in source code. Sorry,
Yeah.
secrets. Like, and by secret we mean like passwords. So you got a username and password for database. Um, certificates, which sometimes just get lumped in with source code, RSA keys, and other sort of cryptographic keys, tokens, so like API keys and stuff like that. Sometimes people extend secrets to stuff like, certain forms of config, like IP addresses and internal domain names and usernames and all of that jazz. I tend to go, yeah, there's stuff you might not want out there. Like, if you accidentally put it on GitHub, its intelligence a bad guy could use to understand your organization, but it itself's not a secret. So,
and there are plenty of tools out there that do this for like repositories and things like that. But we found it difficult to find a good tool to do it for just local files, or if you just have a certain string that you want to check or a file that you want to parse and look for anything. So that's sort of where this came from, I guess.
And so there's a few different checks you can do. So there's deterministic checks. So, for example, checking for the begin RSA. Well, so in this one, I'm actually checking if both the RSA start and end line are in a file. Because, and so that really crunches down on your false positives. A false positive is simply something that triggers a check, but isn't really anything. In this case, by checking for both the start and the end of an RSA private key, your likelihood that you found one's pretty high, versus if I just had like if begin RSA private key in line, go, oh, I found an RSA private key, and then I ran this script over this script, it would alert because this is in. Actually, it'd alert anyway because this is in there too. It'd find the start and end lines. So that's actually. No, I realized my logic here is very wrong because I'm checking if this is in the line. Actually,
no, because it loops through all the lines.
Yeah, so those variables stay set. It means if there's multiple RSA private keys in a file, it'll just think there's one. There is some quirks to work out. I mean,
but that doesn't matter because you'll still get a single alert to say there's something in this file. Go look at it manually. It's not trying to print the RSA key itself. It's just sort of saying there's one in this file.
So there's a whole bunch of other checks we could go and add, and they all kind of boil down to the same sort of thing. Look for something that's this, look for this keyword or look for this kind of phrase that might indicate something. Look for a particular data format. Look for what else? If we're looking for secret, maybe. A particular service's API keys are always 22 characters long, so you look for 22 character long strings and stuff like that. So, but these are all reasonably deterministic. I say that when really deterministic is deterministic, like it either is or isn't, but I'm just, run with me here. The idea is that the probability that you found something that is high, although I would argue searching for the word password doesn't actually always find anything interesting. It often just finds password equals config.password or something like that. Because it's stored in config or something like that.
Or an error message that says your password is incorrect or your password doesn't match or, something like that.
So the next thing to look for are high entropy strings. So this is where stuff gets fun. So I say stuff gets fun. Information entropy. I keep wanting to add a H after the P to like.
Entropy.
It's not entropy. It's entropy. This is a wiki page. So information entropy is like a computer science subject. I didn't do a computer science degree. I did like an IT degree that just focused more on like the engineering side of stuff. But the idea of entropy in information theory is basically to convey a piece of information. So a cool example I saw was, let's say the weather in Melbourne has a 25% chance of being sunny, a 25% chance of being rainy, 25% chance of being cloudy, and a 25% chance of being foggy. So that's 25% each, or 0.25, or 1/4. The idea is how many bits, so if we're thinking like binary, how many unique combinations of, well, how many, for my like dictionary of things that mean those weather events, how many bits would I need? And the answer is 2, because there's 4 things, and to do 4 combinations, unique values. In binary, you need at least 2 bits, because you got 0, 0, 0, 1, 1, 0, and 1, 1 for each state. You can't make that any shorter without risking losing information. I mean, you could probably go, well, I'll send a single 0 for if it's sunny, and I'll send a single 1 if it's this, but if you're trying to send information fast, you could get, confused and stuff like that. So the idea is if everything has a 25% probability, or how many questions would I need to ask to figure out what the weather is, and so the idea is you could ask, is it sunny or raining? If the answer is no, then you just need to then ask, is it foggy? And if the answer is no, it's cloudy. So the idea is kind of that sort of breakdown, that you've got 2 questions you need to ask to figure out all the possible states. Anyway, the whole point is this is really useful in compression. So the idea of, right, I've got a bunch of data that can be expressed in these bits. That then means you can take, our alphabetic characters and figure out all of the combinations of bits you might need, build a dictionary, and off you go. When it comes to so the other advantage of entropy is like a cryptographic property, not a cryptographic property. So the more random something is, the higher the entropy. So 2 ways to calculate this. There's the way if you go and look on Wikipedia, which just simply is, you have to go, what are all of the options and their various probabilities, and then you figure out for a given set of characters how many bits of entropy are there, and it's always going to be between 0 and 2. The other way is the kind of password entropy calculation method. And I realize I am casually running over many, many complicated topics here with this. But effectively, the idea is actually a real simple explanation of entropy. Headphones, when you like neatly coil them up and put them in your pocket, and they come out really, really tangled every time. That's simply because there's more states they can be tangled than not tangled. It's the same way your bedroom tends towards getting messy rather than magically being clean without you putting energy into it. It's because there's more states that your bedroom can be messy in than clean in. Generally, you could say there's effectively one state where it is clean and an infinite number of states where it's messy, which is why it always tends towards messy.
Yep.
The same thing goes for like passwords. That instead it kind of works out to be, the more random your password, the more possible states it can be, like the more possible combinations you could make out of the length and the number of characters. Obviously, the more random it is, and the harder it is to guess. So if it was all A's like I've got here, very easy to guess, because you'd go, well, I'm going to assume their password is all A's, and this one, much harder to guess, because you can't assume much about the password. You basically have to try every single combination to find it, or ask a lot of questions. Now, the challenge with password entropy calculators is they give you a rough idea, but they don't really tell you the guessability of the password, because a password of 10 A's is just as guessable as a random 10-character long password, because they exist in the same getting mathematical probabilities.
It's random, yeah. Through a randomness, there's the same likelihood of it appearing as something else.
If you're going to roll 4 dice, which is 24 combinations, 24 possible values. I don't know how you get anything less than 4 when you roll 4 dice, but let's just ignore that for now. If you were to do that to get every single character the password, there's just as much chance you'd find the good random password as you would the 10 A's. The reality is brute forcing doesn't work like that. It starts at the top and goes to the bottom, plus you chuck in dictionary attacks and known password lists and all of that. But that's all an aside. The reality is a high entropy string also indicates that there is a random password in something, that there is a crypto key, that there are GUIDs. GUIDs aren't always necessarily that interesting. Most of the time they're not. That there are keys and a bunch of other stuff. It also can indicate highly compressed like values. So anything highly compressed is going to appear random because it's had all of that guessability taken out of it. Because if there's guessability in something, there's wasted space. So I think someone had said you take any Shakespeare play and then you just give someone the first word of that play and you say, guess which play it is. And they're going to go, I'm going to need to see a lot more words for me to figure this out. But if you give them everything except the last word and you say, guess which play this is, they're going to know because, well, I mean, presuming they know Shakespeare, which I don't know that much of, but that's the part of this idea is like, oh yeah, it's this. You don't need to know much. So anyway, what we're going to do, and again, that's just a property of good randomness. So if something's poorly random, it might actually not get picked up by scanning for entropy. And the other problem is a lot of false positives as well. So I wrote this super quick function. And by the way, I'm no expert on this, so we'll put links to some useful stuff in there. But I had one course where it showed up. So if I run that, so I've got my... so all you need to do to calculate entropy in the style of how good is a password, which is also useful for what we're going to do, is you need to have the string that you want to check for the entropy. And then all you do is you take the potential options in that string. So when you kind of do this, that's two quotes side by side, which is a blank string, but yeah, everything in Python can have functions attached to it. So if you do like a dot join and then a set across that, so a set will then pull out the unique values from that string. So effectively, I'm just creating a list that contains the unique values contained in the string pass, actually A, which is going to be 1A. And then you get the length of that string as well. So if you notice my first one, I'm printing the alphabet. So the alphabet for the first one, which is all A's, is just A. And the alphabet for the second one, which is that, is that. Because there's basically no duplicates in this password, is there? No, there's not. It's the same character doesn't show up twice, so you should get all the things back. And then you do the base 2 log. So if you remember back to maths, there's like, base 10 log, and then there's like log natural and stuff like that. Log 2 is version 2 of the log function in Python. No, it's not. That's a bad joke. So the base 2 log of the number of unique values that showed up in the password times the length of the password, and you get a value back. In the case of this function and the way this works, this value doesn't tell you anything except the relative randomness between two strings. So the idea, because it doesn't take, if you were going to use this to calculate the potential entropy in a password rule set, traditionally that's around 96 characters, uppercase, lowercase, letters, numbers, special characters is roughly 96. And then you had a minimum length of 10, you'd be like log 2, 96 times 10. And that would give you the entropy of any random password that meets those rules. And we're simply, in this sense, the entropy is simply, if you were going to toss a coin, how many coin tosses would equal the amount of randomness that's in the password. So this many A's is 3.3 coin tosses, rounded up to 4. 4 coin tosses is the amount of randomness in a string of that many A's, so not much. This password is going to come out at 8. The reality is the actual set of characters that generated this password were far more random, but because we have to use what we know about the password, it just comes out at 8. So it doesn't tell you the same thing as like the thing that would tell you what's the entropy of a random password for a general set of rules. This just gives us relative values. And then you have to fine tune this. So getting onto actually the useful stuff, because that was a lot of talking that's probably just bored a lot of people to death. If we look back, we've got a lot of checks going on. So, well, actually not a lot. We've got 2. We've got this check for password variables, check for RSA. I actually haven't looked at this much since the last time I did it. So let's see how we go. Def check for high entropy. Then we want self and file. And we want to go up here from math import log2. Should be the only thing we need, Jake.
I think so.
Because I've got a high level of repeated logic here. All I'm going is like with open file. I've got other logic to go through a set of folders and pull out files, which I can show in a sec for like how we know which files we're going to look through as file underscore text.
Is the live stream where we built this one even on our YouTube as well?
Oh, the live stream for the original part of this might. I don't even know if I got to a point where I wasn't saving everything from Twitch. So,
I was going to say otherwise, go check our previous video, but I have a feeling that it's not there.
Well, actually, I might just do a pass on this for a second. So what this does at the moment, if we go to run.py, just where it starts, just imports. I called it Scrounger. It just sounded right. From scrounge.scrounger import Scrounger. This is the joy of the way I do crap in Python. Effectively, we're saying, actually even better, we'll go to Scrounger. So this is a class, and all it does is it has a so the init function, which we're calling back in run. With this sample underscore files is this folder over here. Go back to Scrounger. So the init just goes, it's initiated with that file path, and then it immediately goes to this files list class over here, which all this does is take a pass, and then run through every single file and folder in that path, and anything that's an actual file it gets the full path of. It ignores folders other than when they show up in the path of an actual file, my bad. And it does, and I wrote this function called isBinary. I actually think I might have also lent on someone else's logic from Stack Overflow, but effectively it'll check if a file is binary. So for files, and it does that through basically statistics.
It's from the magic bytes.
Yeah, that's right.
The magic bytes at the start of a file that indicate that it's a binary.
Yeah, so so not all files have magic bytes at the start to indicate they're binary. So
no,
it then does basically statistics to go, are there a lot of human readable characters in here? If less than 30% of the characters aren't human readable, then false. Return false, which means it's not a binary file. If more than 30% of them aren't human readable, then it's not a binary file. So then it is a binary file. So basically, and we only take the first 1,000 bytes, I think. The first kilobyte. And then we basically run through, and then we go, if less than 30% of them are machine readable, i.e. non-ASCII or non-printable, then continue as if it was a normal file. Because you might have binary embedded in a normal text file and stuff like that. And that kind of largely works. I've got this JPEG file and this that reverse shell we did. Yeah, and they're binary files, and it errors out on those. So that's all that does, and then it builds that list, and so that function gets called here. And then, I don't know, I love abstracting stuff out, which is why I end up with too much stuff. I don't know why that's there. That's not needed, but it's there anyway. And then it has just a list, sets a value for itself for all of the files that are in scope. And then there's the run checks function, which then just gets called. And all that does is for every single file, then start running each individual check. Each individual check for now just dumps out to the console what it's found. It doesn't write to a file or anything. You'd probably want to then refactor this at some point before you'd written too many checks to come up with a better pattern for them so that they're a little bit more modularized, so you don't have to... you could actually just build like a list of all the functions, because in Python you can have a list of like other objects, including functions, loop through those, and then you might have a way of giving them the right thing and like the actual text from the file, and then taking the right thing out. So all we're going to do now to calculate entropy, so for example, this check for RSA just opens the file in that list of files over here, and then runs through every single line. And there's a count variable that isn't set in this one that is in this other one. Okay, never mind. I got excited for a second and it was nothing. It just goes through every single line and sees if it finds something it doesn't like. Really, we're going to reuse that same logic. So we're then going to want to just basically go for line in file underscore text. And then, actually, we're going to want to write an entropy function. So I'd already written one, so I'll just go over here, get entropy. Where are we here? Check for high entropy, and then did I just? Oh no, all good. Oh, that's what.
Because you pasted the def, yeah.
Oh, it just, yeah, the tabbing, yeah. PyCharm's nice because it knows that Python uses tabbing for delineating code blocks. But if you're at the wrong level of tab indentation and then you paste, it will happily ignore the source indentation. At least in my experience. So, then effectively, what we want to do is something like words equals line dot split, and then it's just going to be that, I think.
I don't think Reese has chat open.
No. Do you have chat open?
Yeah, I do.
Good.
He just said Reese. Exclamation mark.
Yes, it's me. I'm doing a lot of talking. Too much, maybe. Check for high entropy, and then we just want to.
This is the kind of stream that Reese's rants are allowed.
I'm not even really ranting.
It's not a rant, no.
I just feel like I'm poorly explaining.
I get that. It's a complicated subject as well, which doesn't help. Yikes.
Why didn't that work? Half a second. Gotta love it when stuff doesn't work the way you intend. Oh, it's because I'm not running the right file.
That is not what it's called.
Genius. Okay, cool. So all I have it doing is dumping out everything split by new lines in every single file. So now I might just go and create a new file called attempt to hide password.txt. So we're assuming, actually, we'll say, yeah, no .py. We'll call go .py. Yeah, we'll add that. So we'll assume that, so normally, you might go the password for something equals some secret, or you might load that from config. So you might go config.password. If you've set it up like that to load stuff from a config file, could be any number of ways of doing that. It's better than having hard-coded passwords. Sometimes devs, to get around this obvious check to see if they've got things they shouldn't have, they might go thing equals, and then I'm going to grab, what's that file that I was dumping?
Passwords.txt, the red one.
Oh, yeah. So here were just some random passwords I generated. So they might go like that and go, if they search for password, they won't find my hard-coded password.
Because I called it thing.
And then I might just be a troll and set password to equal password. And so now if we go back to this one, so we're running through words, but actually what we want to do then is go self. I think in the previous streams I've talked about Python and how it works a bit and stuff like that. Jake had a moment before, because it's been a while since he's touched Python, where
it was a scoping thing, yeah.
Yeah.
I've spent too long in the JavaScript world where scoping is a whole nother thing, if you've ever dealt with that.
So by scoping, we simply mean
variable scopes and
Yeah. So this
this and
variable,
self and all that kind of
so
magic.
so this variable called text out here would only be available if I did like a print text, and that would print lol. And then if I tried to in the init function for this class, the constructor, go print text, it's going to tell me. Well, that won't work, but it'll happily go, oh yeah. Oh no, maybe it will. So, but if I have another variable called text here, and go, it'll print this one and not that one. So there is scoping. PyCharm still doesn't like it when you have stuff that's named the same in different scopes, though. But scopes are just like what level out you're in the function or in the class or in the module, because that's what being at the lowest level in Python is. Okay, where was I, Jacob?
You were hooking in this
Yeah.
passwords.txt into
Self.get entropy, and then we should have, we'll just call it word. So this should then now give me an error, because get entropy takes one positional argument, and two are given because
you need a self.
Got to do that. So that gives me the. So you may notice the sample RSA file and the RSA.pub file are like generating, because those are strings from those files, generating high entropy strings. So it's an example of, well, I might consider them false positives because I've got another check for them. So, okay, so where are we? So we're not worrying about that anymore. We've run our RSA checks. So there's one word it's found. Yeah, that one, which is, I think, the string I did dump in. So now I just need to go at this, actually, rather than printing out the entropy and the other thing. I'll just get rid of those. So the we'll just go return entropy. Actually, maybe what we'll do is we'll go if entropy is more than 5.
5 sounds like a reasonable number.
Return true. So there is some fine tuning in this, and it actually in some ways depends on, again, because we're using one way to calculate entropy. There are other ways to do it, but the challenge is fine tuning it, because there will be English words that are high entropy, like long complicated words like discombobulated have more entropy than the word the. Yeah. So as well, minified JavaScript and even like beautified minified JavaScript, still very high entropy, because it's been compressed. If something has been compressed, it will appear to be random, because all of the predictability, again, getting back to the information theory side of things, has been pulled out, because if you can predict something, then you can go, well, we don't need that there, because we can just take this from this other, the sentence, I have a computer, computers are great. I said the word computer twice. So you can just remove the second reference of computer and replace it with the first, for example. So I'm sure some computer science student who hears this will scream in pain. High entropy equals that, and then if high entropy, what we want to do is print word has, my bad, mental blank there, has been found in file plus file. I mean, we could probably do something so it can count line numbers. Oh, fuck off. Sorry, my bad. I try not to swear, but it's been one of those
First swear of
days.
the year.
Wow, the first swear ever. Normally I try to be... Well, that just shows it's not for kids. YouTube's like got that whole like copper thing now, so...
Yep.
All we need to do is go... I'll just say count equals 0. Count equals count plus 1. Python doesn't have like that whole plus equals thing, which I find frustrating.
Okay.
And then inline. Oh, gosh, helps if I remember that. Inline, and then plus string count. So cast that to a string so that it'll happily show up and that, and won't go, oh, you've mixed your things. Just
Yep.
check that.
And
Cool.
that's a line count, not a word count, just in case you're
Yeah.
wondering why it's indented there and not in that
Yeah.
for loop. Yep.
So that should tell us what line of the file it was found in, starting from line 0, because,
Yep.
well, actually this starts from line 1. So maybe...
But any self-respecting computer developer knows that everything starts at 0.
Because IDE line counts start at 1. Just to be sure, so I don't get the ire of like the programming humor subreddit.
Yeah.
Okay, so there, we've freaked out about those RSA files. There's nothing we can do about that. So this is the problem with entropy. So that's got high entropy, it's decided. Username Bob has an entropy higher than 5. This is where this gets difficult to fine tune. So if I set it to 6, for example, is it any better? Username Bob still has a... Actually, maybe I do need to return the... the entropy. Oh, gosh. Actually, can you have mixed types in a tuple? I guess I'm gonna see true and the value of entropy, and then false and the value of entropy. What's it complaining about now? Oh, it's decided those aren't actually tuples. Oh, how do you do tuples in Python again, Jake?
Good question.
I just remembered it being brackets. Why is it not brackets? This is where you get to watch me.
It is. Yeah, it's brackets.
Yeah. I was right? Yeah. It's just brackets and things in them. It's just... Oops, I accidentally went to fire up burp. No thanks. Okay, yeah. Yeah, and then it should just be if high entropy 0, because that's, I'm pretty sure, how
Arrays start at 0.
Yeah, well, lists and tuples.
Yeah.
And then we just go... At this point, I'd probably actually start using like the syntax where you just go %s and then add all the variables at the end, but with entropy... Oops, I can't spell. P, and then you go like %s. And then dot... why have I forgotten? Oh, what function it is. Dot format. It's just dot format.
Yeah.
Dot format, and then I just go high entropy 1. Nope, that did not work, Jake. I clearly have forgotten how to do this.
I thought it was the string dot format.
This is the quality that you're getting, everyone. Hello, John. Yeah, that's fine. Print S is D years old.
Oh, percent. Yeah.
Oh, yeah. There's a way to do it in a string though. String format. Oh, right. Yeah. It's these ones. It's like that.
Many different syntaxes.
Yeah. Okay, so username equals Bob. Oh, we should probably strip the lines. That's why it's on a new line. So that already has an entropy of 7. So this is where this starts to fall apart.
I guess because the word username is so long and has non-repeating characters.
Wait a second. Yeah, and that's our limitation. So you might actually, maybe you'd use the other form. Because the challenge is we have to use the characters in the past. Oh no, there's E repeats. There's that much. Let me check config.ini though, because maybe it's an issue with the file format. No, it should be just...
no spaces in it.
No, that shouldn't be the problem. No, that should be fine. Oh, wait a second. That's because this is the end of the password checks, and this is the start of the... Oh, my bad. This is what I get for not checking my own logic. For every file, it does all 3 checks.
Yes.
And so it didn't find any RSA keys in this file, but then it goes, right, that has an entropy of 7. That string has an entropy of 9, which is good. All of these have an entropy of 11, which is fine. Where are we though? We want that attempt to hide password file. Yeah, here we are. So that has been found, and password has an entropy of 6. So if we set our entropy to like 7.5, we should start to see it be a bit cleaner.
Yeah. Especially when just the word password itself has an entropy of over 6.
Yeah. So this is, again, the limitation with this particular technique. Yeah. So this string has a whopping entropy of 14, and it's that long. And a password. That's because there's a... things start to be they're limited when your potential string length is less than your total alphabet. So... No. Yeah, so there we go. 9.1. There's that. So we can clean that up a bit, I suppose, by going into this and going and spacing things out a bit.
Yeah, if you put spaces between there.
Yeah. I mean, technically we're gaming it by making it easier for ourselves. The challenge is, of course, those damn RSA files.
Yes.
There's no easy way to like filter those out except remove them to make the results look a bit easier to read. That was an SSH key. Oh, here we go. Yeah. So it's obviously not splitting things at spaces.
Yeah, because it's printing out the line. So it's is it printing the line, but then it says the string of just the password has been found.
Word has been found in file. Oh, that's why the new line's showing up as well. Yeah, because like it should be words equals line dot split space. So it should be splitting on spaces. Because if I go print words. Yeah, there we go. They're split there. So I don't know why it's not cooperating with me.
Yeah, but see above that, it's...
Oh, that worked.
Yeah, so that's what I mean. Like before that, it was printing the line that it was checking.
Yeah, no, that's from the previous
somewhere
check.
else from a different function. Yeah.
So again, the quality you get from us is my confusion over my own code. That's the output from the previous check.
Yeah, I was trying. That's what I was trying to explain.
Yeah, and I was failing to listen. Is my problem.
It made sense in my head.
Yeah, no. I mean, for the minute, I might just move those up to get those out of the way. But now, yeah, I'll move them. What are you doing to me? Sample files config. Oh, there's that one in the config file. Let's get that out of there. This should make it a little bit easier. I mean, that's basically it. So, it's found that. It's chucked a new line in because I need to do like a strip, I think. For now, I'll just do like word dot strip, and then the new line character, and that should make it a bit neater. Yeah, there we go. So it's found our password there, and it's found our password there. That's purely from the first check, where it just goes, I found a password. Actually, we can make this even easier to test. We'll just comment those out.
Just only do the high entropy check. Yeah.
Yeah. So, yeah. It's only found our 2 actual passwords in all the files. So, if I go here, the challenge, of course, it won't find things like, my secret, because I'm not searching for the word secret, is the word secret. So that's the challenge with searching for entropy, but that's pretty much how you do it, is you just, use
But that's why you combine it with a bunch of other checks, like you were saying with the deterministic stuff, is you could have a dictionary of keywords that you would consider interesting words to find, such as password or secret or
I can spell properly. So
key.
Like password strength. So and there's a lot that goes into password strength. Just to, like, turn it back around to where we were at the start. Like, we're kind of coming at the problem backwards. We're finding strings that we think are random by using a function to test the strength of passwords. Because a good password is a random password. Yes. And again, it comes down to these bits of... the bits of entropy we're talking about. So 8 for these ones. Versus if I go and tune it again to, let's say 1. Let's just get every single word, basically. Not Python console, terminal. If I run this. So the word secret. So all we're doing is we go, right.
So that's secret with quotes.
Yeah. What are they?
There's a higher entropy than just the word secret.
Yes. That is the challenge with this method, is you then need to strip quotes, which generally don't show up in secure strings and stuff like that.
Yeah.
Because of the problem with them in programming languages. You need to escape them. So the word secret with quotes, all our function does is go get every unique value, every unique character from that string, so that'd be a quote, an S, an E, a C, an R, and a T. Yeah. Right, so that's S-E-C-R-T, so that's 6 things, plus the length of the thing, which is 6 for the word secret plus 2 for the quotes. So 8. And then 6 times 8 is... Crap, don't do this to me, brain. 48. 6 times 8 is 48. Yep. And then the log 2 of that, and that's going to be 5.5. And so the idea there is given that set of characters, if that was all you could have to make a password, was those 6 characters in the length of 8, and you could have it 8 characters long, then this is simply how many coin tosses would you have to do to get to the equivalent level of randomness? 5. So it effectively becomes 2 to the power of 5, which isn't that many guesses. And then that kind of works out to like... No, that's not how many random guesses, yeah. So that's kind of...
It's the number of possibilities for that.
Well, no, that's...
like the number of possible combinations of characters to
No, that's different. That's then you take the length of the password to the power of the number of options. So that would be 8 to the power of 6. So that's
Isn't that what you
different.
were doing? Oh,
No,
you're
this
calculating.
is how many. This is the equivalent strength to basically just if you tossed a coin. How random is this in comparison to tossing a coin 5 times? And like the more times you toss a coin, like the less probability that you'll get that unique series of coin tosses. So even though each toss is independent, so if you toss it once and it lands on heads, there's a 50-50 chance it lands on heads the next time.
Yeah.
But if you toss a coin 5 times and you had heads, tails, heads, then you've got a 1 and 2 to the power of 5 chance, I think, of getting that same sequence. That's how that works. So that's the 1 in... What's 2 to the power of 5, Jake? Quick, save me.
I have no idea.
I can't do that stuff in my head, and I should be able to. Anyway, so you got that chance of... And that's how strong that password is. If you think of them as randomness units.
Yeah.
And that's the way that those password like strength calculators tend to work. So when they say, oh, this password has the equivalent of 128 bits of randomness, what they mean is that it's got the equivalent level of guessability as it would be to toss a coin up 128 times and get the same result twice. You could kind of think about it like that. I'm probably wrong, but the idea is the more bits, the harder it is to guess. But again, our challenge is we're not actually using the entire alphabet. We're using the characters in the word to guess the entropy, which means we run into the limitation of complicated English words will confuse this thing. JavaScript confuses this thing, which is why entropy checks are a handy guide, but they're not an absolute, I found something, which is one of the problems in like code analysis tools.
Yes.
That they sometimes try and find high entropy strings and don't find high entropy strings. Not API, GUIDs. So if you had a GUID that like one of those long unique IDs that really wasn't a secure thing, it'd trigger. So that's probably that. And fully acknowledging that's probably not the most auspicious start to the year of streaming.
But that's, yeah.
Got to start somewhere again. And again, this is my like layman's understanding of this stuff, which is correct enough conceptually, I'm willing to say, but the details of it, like there's a bunch of fairly good YouTube videos on like, if you're really interested in this stuff, again, it's computer science sort of stuff and is actually more often used for, I've got to send a lot of information from A to B. So the idea is like what the weather is actually a lot of information. But you can, in your actual 4 states, raining, cloudy, sunny, foggy, you can actually get down how do you communicate all of that information down to two bits. And same with Shakespeare. The first word of a Shakespeare play, you can't tell what Shakespeare play it is. So to understand it, you're going to at least need, let's say, if you knew your Shakespeare, you'd understand after the first character's speech, because they always start with some opening monologue. So you'd need another like 300 words before you could guess. Whereas if you had everything but the last word, you wouldn't need another single word because you'd probably know it off by heart. So no more information. And that's like, it's a complicated subject that a whole bunch of computer science and the way computers work is based on. I mean, it's also used in like noise, like if you're trying to transmit things and you get noise introduced and stuff like that, it can tell you if like noise has been added to stuff and stuff like that and all of that sort of stuff. So that's probably it for me. Have you got anything to add, Jake?
No, not other than we didn't pick an easy topic to start the year on.
No, I am willing to admit that. I'm feeling that one is the truth.
That's okay.
Yikes!
We're getting back into the swing of things, and
things should start to get more interesting soon. We'll get back to. We got some interesting stuff planned.
I know. Yeah, even though we said that we're going to be scheduling and planning and doing all that sort of thing, we did only plan this stream yesterday. So
Yeah. But don't worry, we
hopefully-
also plan next week's and the weeks after. So
exactly. So hopefully from now on, they should start to be a bit better, smoother, more organized, all that stuff.
yeah. What else? Gosh, there's other things that have just slipped my mind.
Don't forget to do all that YouTube crap that everyone else tells you to do, but we're not going to tell you to do it.
What YouTube crap's that?
Because if you use the internet, you know what to do.
Yeah, like, yeah. Tell all your friends.
Tell all your friends.
We promise we will get better and better prepared.
Yeah.
All right, guys. On that note, have fun.
Bye.